Okay, so for this thing pair share, we're going to calculate the angle of elevation using the inverse sine and then later the inverse cosine functions. Now, we've already done this using inverse tangent. So we know our answer should be 8.1 degrees and 3.3 degrees. Okay, question you might have is then if we've got the answer, why bother? Because you won't always have the slope of the hypotenuse to work from. You may only have the sides of the right triangle, but no information about the diagonal, the slope, the terminal side of the angle. So you won't always be able to use tangent. So it's important to learn, understand, and know all three trig functions. But we will be constructing the same right triangles as we did up here. So let's get started with that. The first thing to look at is we're trying to do this using inverse sine. So let's first look and see what sine of an angle is equal to. So thinking of SOHCAHTOA, it's opposite over hypotenuse. Okay, now we're interested in the angle of elevation of Old Priest Road. So I'm going to put a subscript O like that. Now let's come over here and look at our data and see where that's found. So Old Priest Road is represented by these solid data points of distance versus altitude. And so here we have our start point, and that's represented here. So we would label that point x1, y1. And then our end point, which is up here, and we'll label that x2, y2. And you'll see why in a minute. So from our end point, we'll draw down to our start point where we're going to draw over, and that creates a right angle. And inside of this right triangle, if we think of this horizontal line as being the initial side of an angle, and we draw counterclockwise from our initial side to the hypotenuse, which is the terminal side, that is the angle of elevation of Old Priest Road. Opposite this angle, okay, is what we call the opposite side. So that's the opposite side for our Old Priest Road right triangle. And then the side adjacent to the angle is our adjacent side. So let's see here, ADJ, 0. And the side opposite the 90-degree angle, that is our hypotenuse, and we're going to need that as well. All right, so in order to kind of fulfill this relationship, we need to know the lengths of the opposite and the hypotenuse. All right, but we're also trying to find this angle of elevation. Okay, so that would be theta O. Well, if we do a manipulation of this, so that's our sine function, our inverse sine function takes this ratio of the opposite side to the hypotenuse, and it outputs our angle of elevation. So if we can find the length of the opposite side and the hypotenuse, we should be able to get the angle of elevation that we need. All right, so how do we get these things? Well, let's first look at maybe getting this hypotenuse. And so to get the hypotenuse, we can use this distance formula, which is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, x2 is going to be this value. So we have 9,815.52 minus x1, which is 0, and then that'll be squared, plus y2, which is 2459.2, no, 0.6, 0.6. Minus y1, which is 1070.2. And then that will be squared. And then the square root of all that. All right, so let's do that calculation in our calculator. So we'll do this both with Texas Instruments and NumWorks here. All right, first let's turn the calculator on. All right, so first thing we want to do is we want to do the square root. And I'm going to put parentheses. And we need 9815.52 minus 0. Okay, and that's going to be squared. So I'm hitting this x squared button, which will automatically put that square. And we want to add to that the difference of the y's. So it's 2459.6 minus 1070.2. And that 2 is going to be squared. Okay, so before I hit enter, let me do the same thing over here with NumWorks. So I want the square root. You can see what I'm typing in down here. All right, so 9815.52 minus 0. Okay, squared, so there's an x squared button right here. And then we'll do plus. And you can see as I'm typing it, it's putting it underneath this square root sign, just like the Texas Instruments did. Okay, so 2459.6 minus 1070.2, and then I want to square that as well. All right, so if I hit execute here, I should get 9,913.3 and some change. And if I do hit enter over here, all right, I get the same answer. Now, you don't want to do any future calculations with rounded numbers. So we would like to use this fully accurate, version of this calculation that we just did. So what I'm going to do is I'm going to take advantage of the calculator, and the calculator has memory. And I'm going to store this entire number in memory. So how I can do that with the Texas Instruments is you have a button down here in the lower left-hand corner. It says STO with an arrow. That means store. So if I want to store the last number that I just calculated, I can hit store, and I can put it in a variable in the calculator. So because I'm trying to calculate the hypotenuse, I'm just going to maybe use the letter H. So the letter H is in green. So that means I have to hit the green alpha button and then this caret button. And so it's going to take my answer and store it in this letter. Okay, it did that. Now I can do the same thing here with the NumWorks calculator. It too has a little arrow. You'll notice there's a little orange arrow here in the upper left side of this X to the Y button. So to make that happen, if you want to store this last number, we can hit Shift, which is orange, and then this button, which will enable this orange arrow. So it stores the answer in. And we want to also put that in letter H. Now I'm just going to let this be a lowercase h. So I'll just hit the alpha button once, and then this cosine button, which has the letter H on it, like that. And I'll hit execute. Okay, so it just took this value and stored it into H. Okay, that's going to come into play later. Yeah, okay. So it's going to be 9,913.3 and some change. So let's get back to our problem here. So this came out to 9,913.3 and it kept going. And we're storing that in H with the Texas Instruments or lowercase h with numworks. All right. Well, let's take a look now at calculating our angle of elevation for old pre-Strode here. So this is going to be, let me pause here. Okay, so I'm resuming. Just wanted to correct a little Microsoft Word issue. All right, so now we're going to have calculating this angle of interest. We're going to have inverse sine of the opposite side divided by our hypotenuse. All right, so how do we get the length of our opposite side right here? Well, that's going to be the difference of our y values right here and right here. So what we'll do is for the length of the opposite side, it's going to be 2459.6 minus 1070.2. And that's going to be divided by our hypotenuse, which we said was letter capital H or lowercase h. So this way we don't have to type in that number. It's already stored in the calculator. All right, let's see what that comes out to. All right, yeah, this will be good. We'll just go ahead and leave that up. Okay, so what we want is we want to do the inverse sine. So it's in blue here. So I'm going to hit second and sine. So we're doing the inverse sine. And I'm going to put parentheses because this is where I want to do the subtraction of the numerator first. So 2459.6 minus 1070.2. Okay, that's our numerator divided by, okay, the number that we stored in uppercase H. So I'm going to hit the green alpha button and then this caret button to get the capital H there, right parentheses, and let me hold it on that because I need to copy that on the numworks calculator, okay? Okay, so we need to do inverse sine. So instead of having sine with a -1, the numworks calculator has a sine. Okay, remember that was an equivalent to saying arc sine or inverse sine. So we need to hit the orange shift button first, sine button second. See, it says arc sine there. And then we want to do parentheses for the numerator. So we got 2459.6 minus 1070.2, right parentheses, and we divide that by this letter H. That was our hypotenuse. So I'm going to hit alpha and this cosine button because that's where the letter H lives. There we go. And if I hit, oh, I see a problem. I think it's going to calculate it. It's going to give me radians here. Oh, and it's going to give me radians here. Okay, let's see if I'm pretty sure that's going to be a problem, but let's take a look. Yep, it's giving me my answer in radians and not degrees. Okay. I'm glad this happened actually, because this is where you need to pay attention to what mode your calculator's in. So here it's in radians, but our answer was in degrees. We were expecting, what, 8.1 degrees, something like that. So let's go change both calculators to degrees and we'll redo this calculation and it should be okay. So on Texas Instruments, if I hit mode, you can come down here to degrees and then quit. Let me come up here and hit enter and do that again. And there we're getting 8.1 degrees. So same formula, but this is when it was in radian mode. This is when it's in degree mode. And so our answer is in degrees. Important lesson there. All right, let me do the same thing here with the NumWorks calculator. So if I hit the home button, and then a shortcut to get to the settings is from here at the home screen, hit 0 and 0. And then under angle measure, click OK, go down to degrees, click OK. And let me go back home. And I want to go back to the calculation app. So I'll click OK. Let me come up here. Oh, did I see it? I thought I just saw it briefly go to degrees. Am I wrong? Anyway, let me just go ahead and select this equation again and hit enter. And then there's my degrees. So same equation. This is when it was in radian mode. This is when it was in degree mode. A little curious. If I went up to this one and I hit these three dots, let's see here. Yeah, I was hoping it's giving us additional results. I mean, this is neat. It's giving us this graph, but all right, let's just leave that out of it for now. Okay. So you can see we're getting about 8.1 degrees on both calculators. Let's come back. So this is 8.1. All right, so that is our angle of elevation for Old Priest Road, which is what we expect. All right, let's do the same thing, but let's do it with New Priest Road, which is right here. So it's going to have the same x1, y1, but it's going to have a different x2, y2 because we've got a different endpoint right here. And if we draw down from here, and if we draw over, this creates a right angle. This is our angle of interest, which is our angle of elevation for New Priest Road. Here's the opposite side for New Priest Road, adjacent side for New Priest Road. And let me come over here. Oops, let me go ahead and circle that. All right, so now we want the hypotenuse for New Priest Road. That's going to be the square root. Going to do the same thing we did before, except our x2 and y2 is going to be different. So now our x2 is this number, 24,055.68. It'll be minus 0 squared plus our y2, actually, which is the same, 2459.6 minus y1. And that 2 is going to be squared. So let's see what that comes out to on both calculators. So we'll do second to get square root and 24,055. Oops. 24,055.68 minus 0 squared plus 2459.6 minus 1070.2 squared. All right, let me leave that one up. Over here, let's do the same thing. So square root, easier to watch down here what I'm typing in. So this will be 24,055.68. I don't have to put minus 0. I'm just doing this so, you can see what and why I'm doing what I'm doing a little bit better. 2459.6 minus 1070.2 squared. Okay, so let's execute that. 24,095.7 and keeps going. And let's do that over here. Yep. Okay, that looks good. Let me store this into variable j this time. So let me hit store, just down here, alpha, and then here's the letter J. Enter, good. And over here, this is the store button, orange arrow. So shift this, and I want to put it in letter J, which is this pi button here. So I need to hit alpha first, then this pi button to print a lowercase j, and there it's storing the value there. Okay, let me catch myself up with what I'm doing. So this came out to 24,095.7, and it kept going. And I stored that in capital J or lowercase j, depending on the calculator. Okay, so we're going to need this hypotenuse down here. So the inverse sine of the opposite of New Priest Road over the hypotenuse of New Priest Road, which will be the inverse sine of, okay, so now we are focused on this opposite side. So actually, the values here are going to be the same as those. Okay, that looks right. So we got 2459.6 minus 1070.2 all over. This will be capital J or lowercase j, depending on your calculator. Now we expect 3.3 degrees to come out of this. Let's go ahead and do this. Okay, so second sine, there we go. Parentheses, 2459.6 minus 1070.2. Again, these two numbers come from the difference between the ending point and the starting point y values, 2459.6 and 1070.2. The difference of these two numbers will give the distance between this number and this number here. Okay. And let's divide that by j. Okay, so we'll hit alpha and comma. And let's put right parentheses there. And let me keep that up so I can put it here. So shift, sine, it gives me arc sine. And then I want to put 2459.6 minus 1070.2. And that's divided by lowercase j. So alpha pi. There we go. And so we get 3.3 degrees, 3.3 degrees. Yeah, pretty good. All right, so let's come back here. And so we get approximately 3.3 degrees for our angle of elevation for New Priest Road. Okay. So, those are the hoops we got to jump through if we wanted to calculate these angles of elevation for both roads using the opposite side. Now, it's also a useful exercise to do the same thing since we know what the answer is supposed to be, but instead using inverse cosine instead. So we've done a lot of the work already, so it's not going to be too much extra work here. Half of the work was just getting this hypotenuse, and we already got it. So while we already got it, let's use it, and let's take a look what this would look like as a consequence. So, um, how come I'm not seeing any of my drawing tools? Oh, there we go. Okay. All right. So, let's first look at our definition of cosine. Cosine of an angle is the adjacent side over the hypotenuse. So therefore, um, calculating our angle of elevation for New Priest Road is going to be the inverse cosine of the adjacent side for New Priest Road all over the hypotenuse of New Priest Road. Oh yeah. Okay, good. Um, oh yeah. Okay. Sorry. I just got a little confused myself a little bit. Okay, so we're doing that for Old Priest Road or New Priest Road. Having a hard time keeping these two separated. Okay, and so that's going to be equal to the adjacent of the old over hypotenuse of old. And you know what? Just to keep things the same, since I did old over new, let me do that because I want to try and keep this as the same as possible. Old over new and old over new. Yeah, let's do that. Okay. So inverse cosine. Okay, adjacent side. So the adjacent side is actually going to be the length of this segment right here. So the length of that segment goes from 0 to 98, 15, 52. All right, so this numerator is going to be 98, 15, 52, and that's divided by the hypotenuse, which was h or lowercase h. And we want to go ahead and write it down for New Priest Road. We can go ahead and do that. Let me choose. Do I have another color I can use here? Yeah, let's use this purple color. So the adjacent side for New Priest Road is going to be all of that, which is going to go from 0 to 24, 55, 68. So that's going to be 24,055.68 divided by J or J, just like that. All right, so this one's a little bit easier, but let's take it one step at a time. Okay, inverse cosine. Okay, it's right here. So second cosine, 9815.52 divided by, this will be capital H on this calculator. We can't do lowercase letters, as far as I know, on the Texas Instruments. So that's why we're kind of locked in here. And let me come over to NumWorks. And let's do shift cosine and 9815.52 divided by H. So we're going to do lowercase. We could do uppercase, but I just want to keep it simple. So just do alpha H. Execute, get 8.1 degrees. Execute, 8.1 degrees. So just what we expected. So this one should come out to 8.1 degrees. Angle of elevation for Old Priest Road. And let's do it now for this last one, and then we'll be done. So inverse cosine of 24,055.68 divided by capital J. So you see how important it is to make sure that you document everything. Inverse cosine. Because it's hard to keep all of this stuff straight. This will be lowercase j. So alpha and then this pi button. There we go. And we should get 3.3 degrees, 3.3 degrees. And that's the angle of elevation for New Priest Road. Okay. So, here we were able to use, the very basic definition of a trig function and its inverse trig function, for a real world example of the angle of elevation of state routes in California. And it's helpful to try all three trig functions because we know what the answer should be, so we know we can get it right. But it just goes back to just the elementary definition of what cosine is. Oops. Elementary definition of what cosine is and what sine is. Okay. And just working from that basic, simple premise, real world problems, do take a lot of extra calculation and a lot of attention to detail. But you know what? You do it and you can do engineer type work. All right, so let's go ahead and end this video here. Let me know if you have any questions.